guess I'm the technical director. I'm part of a collaborative effort to try and put together the first Violet unit, which is going to be the first open source, open hardware, direct air carbon capture device.
So my name's Adam Aston, and I'm a journalist and energy and climate writer with a long background of looking at the way both the private sector and corporations and innovators and technologists have been looking at the challenges around climate, as well as the measurement and scientific work in the space. One of the biggest challenges in the climate space, of course, is figuring out if we can't reduce all the carbon we need to, how to remove it. The OpenAir Collective is dedicated to figuring out ways to hasten the speed of that development in an open, collaborative way, touching on a whole variety of people. So I just got involved, and we've decided to sort of launch into a series of video conversations with the community that is our collective. And today I'm meeting with Chris Chung to talk a little bit about some of the basics in the space and get up to speed on where we're at and where we're going.
So, hi everybody, I'm Chris Chung. I'm on the R&D team at OpenAir. I guess I'm the technical director. That's kind of a loftier and more generous title than I probably deserve at the moment. I'm part of a collaborative effort to try and put together the first Violet unit, which is going to be the first open source, open hardware, direct air carbon capture device. And the intent of this research and development is to put together a list of materials that allows anybody anywhere with access to basic house construction type materials to assemble their own machine and kind of join us in this sort of endeavor to do the sort of expansion, iteration, and improvement of direct air carbon capture on a home scale, on an individual scale. When I'm not doing R&D with OpenAir, I'm an adjunct professor of game design at NYU and CUNY. I'm an indie game designer, and in my past life, I was a submarine officer with a systems engineering background from the Naval Academy.
Which is super cool. As a first question, one of the neat things about this group is how many game designers and kind of software nerds are involved. I describe myself as like a fan of software nerds. I'm not capable, but I've worked with a lot of them, and I'm always impressed by the way they think and work. So I'm curious, among other things, to hear a little bit about one of the neat ingredients of this approach is that it's relying on the open source model, which, as far as I know, kind of rooted and grew and flourished in the software world. Could you kind of explain why that would allow us to move faster and end up with like a solution that all kinds of people could help build and also improve on around the world?
Yeah, I think the credit really goes to Matt Parker and his insights and his background. He's one of the founders of OpenAir, and he has an extensive background doing a lot of like hardware hacking and physical computing. And it's from his experience that he kind of saw this opportunity to push this hacking open hardware approach to kind of solving this problem. I think the entire approach is really sort of beneficial from the fact that it doesn't rely on perfect information. Mm-hmm. It's very sort of operational in its thinking. How do you get stuff up and running? How do you improve it? How do you formally identify problems and address them over time and not get hung up on the minutia? It kind of really injects a lot of momentum into the act of creating. Matt saw, and what we've kind of seen through this sort of like approach is that once you start privileging action as opposed to kind of solving every edge case and possibility before you start doing, you get a lot of momentum. You put some stakes in the ground, you get things accomplished, and from there you can sort of improve. And I think what makes our specific group, functional is the fact that we have the Matt Parkers who are kind of pushing us forward, saying, let's get stuff done. Let's figure it out as we go, which kind of gives us this sort of like forward momentum. But we also have people like Peter Loken, who, and he wants us to, dot our I's and cross our T's and get our measurements and do good science. And this, I think, sort of like push-pull sort of dynamic is what keeps us making smart decisions to the best of our ability while trying to keep the entire project moving forward the best we can in COVID context.
One of the experience writing a little bit about technology innovation, one of the neat things about open source and most classes of technology from chip design to automotive is that every effort to chase the same goal often ends up having to solve some of the same basic challenges, like a billing function on a website. Why waste the effort duplicating that 1,000 times across 1,000 business models? And as open source kind of builds on kind of existing code, people can borrow it and learn from it. And one of the neat things about applying that kind of build and borrow and not being sort of fussy about intellectual property, which is both really important to innovation but can slow it down, is that it allows us to sort of experiment freely without worry, but also take what a team in Hong Kong might have perfected and another team in Geneva sort of built on, and then starting there rather than having to figure it out. With all that said, I'm curious. We're some time into the OpenAir effort right now. Kind of how would you describe where things stand? How have we begun to work on the collaborations? We're in a time of COVID right now as we record, and we're talking a little bit about how maker culture is really an exciting in-person vibe we all want to be part of. It's a little bit harder to do right now.
Yeah, so let me kind of break down my answer into parts. First, like where we are as a project, big picture, and then where we are on the path to getting Violet version 1.0 sort of stood up and released to the public. So big picture, around February or March.
In 2020.
In 2020.
Yep.
The OpenAir Collective received a small quantity of a sorbent, which was similar enough to the version that was outlined in white papers from our technical advisor, Tao, who's a scientist in China. He's kind of like written the white papers that are sort of our guiding documents. And we are able to obtain a sufficient quantity of a similar enough sorbent for us to start testing so that we can validate our measurements as well as the sort of like support hardware to see if this thing would actually work. And then that first session that I was a part of back in March was a test to see if the sorbent itself actually functioned. And that session was incredibly insightful and a calamitous disaster. Nothing worked, right?
Like all of the best things in life, right?
Right. We set everything up, we drew diagrams, we recorded videos, and everyone was excited. And then somebody read the fine print. It's like, oh, we have to like chemically prep this sorbent. Right now it's inert and it's going to do nothing. Mm-hmm. We've been waiting for it to do something that it is just not going to do. Mm-hmm. So from there, we broke up tasks and tried to figure out what our next steps, but it became clear that there's no moving forward without the sorbent. So Peter Loken took the sorbent and he kind of took charge of prepping that sorbent material. In the meantime, COVID kind of really hit New York pretty hard at that point, and we all kind of went our separate ways, and we tried to parallel path this process of getting us to Violet 1.0. So Peter was doing a lot of the sort of like prep and initial testing on the sorbent. Meanwhile, we were trying to come up with the first sort of design. And what we kind of figured out along that endeavor was before we could even get there, we needed a good test bed to vet the function of the sorbent. And so that kind of took us on this right angle turn where instead of working on making a Violet unit that would kind of do the work of capturing and selectively releasing CO2 from the atmosphere, we just needed a way to measure how much was going into these cartridges so that we could start doing testing on what direction should the air flow, how much density can we really have, how big of a fan do we need, what is the sort of internal volume of this unit so that we can kind of get a sufficiently high reading for the sensors that we actually have and are available for a reasonable price for a maker community that probably wants to do the same thing. And so the act of trying to assemble the unit revealed that we needed a test bed, and working on the test bed revealed that we needed very specific and more rigorous testing before we can really move forward. Over the last 2 months or so, Peter has managed to get some of the initial testing done which has kind of like confined the design parameters of what the Violet 1.0 unit should look like. And so we just put together a parts list with the expectation that everything is going to work. And so we're waiting for this sort of second round of testing to kind of get us some other parameters, which is going to determine part selection and like orientation and some of this other stuff. That's kind of where we are right now, both in terms of the big picture project as well as in the kind of fine details of what's holding us up from having Violet 1.0.
Got it. You alluded to the researcher in China who kind of pioneered the model that OpenAir is, this arm of OpenAir is looking at. And it might be helpful, if not inspiring possibly, to say he's built his own prototypes of these models. And one of our challenges is to take a bench version of this, kind of bristling with tubes and wires and sensors, and figure out a way to kind of turn it into a toaster for a real impact. Does that sound right?
Yeah, absolutely. Tao's version that he has in his lab that he uses to validate his own sorbent has the advantages of being built in a university lab. He's got pressurized motive air. He's got all kinds of fancy doodads and high quality sensors and all of the good stuff that we wish that everyone just kind of had access to. Also, one of the reasons why his sorbent and his cartridges are so efficient is because he's able to grind down and embed the sorbent onto the face of PVC sheets. And you can only do that by using noxious chemicals and all this other stuff that you can do if you've got a lab. But there's no
hood
way.
And
it's kind of a tall ask to say. It's like, hey, you want to make a Violet unit? You need a fume hood and like a splash guard and like all this PPE, and then you need a license to kind of purchase these chemicals in the first place. And so we're trying to figure out what is the toaster version of this, the least fancy. We know that we're going to give up a lot of efficiency. We know that we're going to give up a lot of efficacy as well. We're having to make these concessions. So what we're trying to do is get to the point where, for a reasonable cost, we can sort of replicate the mechanisms that he's done in a more idyllic setting. But yeah, like he has one, and Tao's proved that it works, and he's like written up for everyone to kind of see and appreciate. And so now we're trying to do the simple, cheap version of what he's doing.
Things I'm curious about, which have come up in piece and part throughout conversations I've had getting to know the project with Chris, but that I've never really heard said in full aloud. And the two of them are appeal and coolness of this project as it relates to kind of maker culture. The idea that we can look to and adapt a whole community culture and set of tools and processes that have grown up around the handheld consumer technology sort of layer of software and circuit boards, and adapt it to something as kind of crazy and potentially impactful as climate change. And then its sort of twin or sibling is why open source, why those two sort of ingredients would make this approach potentially so fun and also impactful.
From my part, I think it makes a lot of sense. I think we as a society, a consuming public, have a tendency to expect innovation and breakthroughs and all these other things to come from moneyed institutions and brilliant individuals. But the reality is that there are technological revolution, which are kind of born from that sort of like brilliance and money and opportunity. But a lot of advancement really kind of comes from improvement, evolution, right? And I think that's where the makerspace and general public hacking community and a public engagement-based approach to solving this problem makes a lot of sense, because we're at a point where those revolutions have already taken place. The technology exists, and now it's about approaching it from a perspective that gets it to a point where it is streamlined and affordable and accessible. And that's something that can be improved through usage and just passing it through lots of different people's hands. And I think right now we're at a point where if we can get this project up to this point of like minimum viability, so that you can just Amazon all the parts that you need to assemble all of this, and then you can get this kind of like sorbent cartridge, which is the sort of like magic piece in all of this, then you really can just kind of put it out into the wild and let people make these iterative improvements that make it cheaper and more efficient, and start collecting data data that allows us to feed the science so that they can start making improvements in the sort of like design and production of this stuff. So for my part, the thing that I really kind of found exciting is that we're at this crux, right? The hard work has been done. The sorbent exists. The technology exists. Now we just need tubes that move air and pipes that spray water, like the simple stuff, right? And that's very doable. You know, it's kind of at that point of innovation that feels like doable on a human scale, right? Like the toaster was this like massive sort of invention in like Americana, and it was possible because it only required springs and heating coils and kitchen timers. And I think that's where we are with this sorbent thing. We're at the toaster stage of doability, right? Like we understand pumps that move water and ducting that moves air. So it feels accomplishable.
I love that analogy. It makes me think of the world's biggest toaster at some point, which we may need in this sort of setup. Maybe as a last question for today, on the note of how we all got involved and how others are involved, I wanted to kind of harp on the fact that in the months I've been learning about OpenAir, I've seen on screens, talked with through text, a couple dozen people, and really am excited by how it's been growing, but also the diversity of the people involved. I've only had a quick kind of, glancing conversation with quite a few, but it includes scientists, designers, people still in maybe as young as high school and college, and people as senior as like well into their careers. As I mentioned, I'm a journalist who just kind of got obsessed and interested and fascinated in energy and environment a long time ago. And so built a kind of a layman's obsession with it. But one of the neat things I had heard about you in our introduction, besides being a game designer, you also come to us from a military background and served some time in a place where removing CO2 from the air is really important. I wanted to just, I think, raise that as the final point maybe for today's conversation to emphasize how, again, this technology exists. It's been used in a long time, and in some cases for very, very important reasons. Getting it to big enough to change the global planet's atmosphere is another challenge. But tell us a little bit about your experience that kind of sort of predates all this.
The way that I kind of found out about OpenAir, Matt is a professor at NYU's Game Center, where I'm a adjunct professor. I see him around, and he's been a long-time friend and mentor. And he told me that he was working on this OpenAir stuff. He was working on some of the previs visualizations to kind of explain what the hardware ultimately aspired to do. So I just kind of happened to be in his office when he was working on this stuff. And we actually got into a whole conversation about CO2 scrubbing. And I was really kind of interested because this seemed very adjacent to the sort of technology and the real sort of hardware that exists on things like submarines. Obviously, the submarine space is completely separate. They've got their own sort of operating parameters and requirements. And so they're using different stuff entirely. But this was still very familiar to me. It's like, okay, like it's a known problem. What is it about the old way that's not viable for this other sort of context? And then, like, what are some of the transferable skills and knowledge that I've had from just doing submarine stuff that might help putting this R&D thing, the R&D version together? And so originally I had no idea who was already a part of the project, what were the sort of like captured skill sets and stuff. And I really kind of went out of curiosity because it seemed cool, and it was on a Saturday, and Matt was just so passionate about OpenAir. So I stopped by, and I kind of realized it's like, oh, some of the weird trivial stuff that I just kind of have rattling around in the back of my brain, like you should name valves, right? You should give them names so people know, because if you say it's like the third one, no one knows, because it's just,
no one knows what that is.
There's tubes everywhere. There's all these different positions. I'm like, okay, I can make everyone's life this much easier, right? Just give the valves a name, and that way we all know what we're talking about. It's like, okay, now the valves have a name. They should be labeled, right? And so it really just kind of started from this contribution of, it's like, how do I make the work that people are trying to do that much easier? Since then, some of my engineering background has kind of proven to be helpful. Engineering, I believe is kind of like halfway between science and design, right? It's the thing that allows you to kind of operationalize and kind of manifest those two different ends. So I kind of started doing the work of being the translator between the designers and the science. And that's kind of how I ultimately found my place in this project. But you're right, there's this huge diversity of people that have kind of come into the project, and it's in no small part due to the sort of like charisma and passion that Matt, Ari, and Chris have, and their ability to sort of like kind of infect people with their enthusiasm and get people to kind of stop by and get excited about the project. And I think right now it's small scale and it's really nebulous, and we're trying to kind of apply a form to thoughts, which I think attracts a certain type of personality. A lot of people are chomping at the bits to kind of inject their perspectives and their expertise into this, and we're working really hard to kind of like get it to the point where we can start applying all of these different people's sort of expertise to this thing. We need something for them to improve. And so we're trying to get it there. It's
an exciting moment. I will say, I think amidst the longer lived frustrations and worries over climate worries, and now the fresh set of COVID anxieties, it's difficult sometimes to understand what you can do as a person beyond composting, reducing use. There's a lot of decisions we face and wrestle with. And I think especially for younger people, the idea of I have to take some action, I have to do something to kind of connect my future to sort of lowering the risk of what we're looking at. And there are a lot of ways to do it. They're all great. Many are about personal decisions. But one of the things I'm really excited about this is that it is connected to a really potentially impactful and fascinating kind of technical path to do something that, I hope will be solved on many fronts in many ways around the world, but could really make a big difference. So maybe that's a cue to future topics for more conversation. And I think you and I are, along with some of the cast and names you've mentioned, will continue to be part of building this video conversation library, getting some of those other folks pulled in. So maybe we'll call it there for today.
Perfect.
Sounds good. All right. Thanks, Chris C.
Thanks, Adam.